In today's math lesson, we're going to solve advanced linear equations. I have 4 suggestions that might help you solve for x. Let's see if they do. My first suggestion is to draw the river through the equal sign to separate the left and right sides of your equation. It is really helpful just to identify very clearly which side is which so that you can move things across the equation smoothly. All right, so we have a couple of if statements. So the first if, suggestion number 2. If you have parentheses in the problem, then divide to get rid of them, and you will divide on both sides of your equation to do that. Our second if, and our suggestion number 3, if you have more than one variable on the same side of the river, combine those like terms using their operation, adding or subtracting, that's in the problem. Our third if and fourth suggestion, if you have a dividing problem with a variable on the bottom of the fraction, you're going to multiply like normal to get rid of the fraction, and then see what happens. This will become less scary, pretty simple, fairly quickly. Example 1. We're going to solve for q, where 17q minus 10q is equal to 7. Now that I've drawn my river through the equal sign, separating the left side of the equation from the right side of the equation, let's start solving. We saw in the introduction that there was a hint about whether or not you had variables on the same side of the river, if you had more than one of them. And we do. So that's what we're going to do first. Since I have 17q minus 10q, both on the left side of the river, we're going to combine those. And so if it helps you, think of those q's as something tangible, like queens. 17 queens minus 10 queens, well, that is 7 queens, or 7q, which now equals 7. Now, it's really simple to go ahead and finish solving for q, knowing that a letter and a number, a variable and its coefficient side by side, are multiplying. And to get rid of something that is multiplying, you divide. And when you're getting rid of something, what you do on one side of the river, yes, you have to do on the other side of the river. The purpose for doing this is to cause those 7s on the left to cancel out, thus leaving us q is equal to 7 divided by 7, which equals 1. And there you go. Example 2. We're going to solve for b, where negative 4 times the quantity of b minus 10 is equal to negative 20. Now that I've drawn my river, separating the left side of my equation from the right side of my equation, let's see what we've got. In the introduction, we were given a hint, and it said if there are parentheses, which there are, then divide to get rid of them. Okay, so divide what? The number that is sitting in front of the parentheses is currently multiplying. Any number that is directly attached in front of parentheses is multiplying to the quantity inside. So the opposite of multiplication is division. And we have learned that what you do on one side of the river, you must also do to the other side of the river. And the whole purpose of that was to make the negative 4s cancel out. This leaves us with b minus 10 on the left side of the river, and negative 20 divided by negative 4 on the right side of the river gives us a positive 5. Okay, now we can finish solving for b by getting rid of the 10. So b minus 10. The opposite of subtracting is adding. And again, what you do on one side of the river, you must do to the other. And the whole purpose of adding that 10 was to cancel it out. And as a result, we have a final answer of b equaling 5 plus 10, makes 15. And there you go. Example 3. We're going to solve for W, where 16W minus 8W plus 4 is equal to 20. Now that my river is drawn, let's see what we need to do. We again have two variables on the same side of the river, so we're going to start by combining them. Even though there's a third term, we know that this third term does not have a variable of W with it. So I can't add in the 4 with the 16 minus 8. So we're going to just do this 16 minus 8 first, which gives us 8W. And then we write the rest of our equation. Plus 4 equals 20. Okay. Now that we have this taken care of where my variables have been combined, we get rid of the term that is adding or subtracting. So this 4 is currently adding. To get rid of it, we do its opposite of subtracting. And what you do on one side of the river, you definitely have to do to the other. And the whole purpose of subtracting those 4s was to make them cancel out. This gives us 8W equals 20 minus 4, which is 16. Finally, we can get rid of this 8 by doing its opposite. A variable and its coefficient side by side are multiplying. And the opposite of multiplying is dividing. And again, as always, what you do on one side of the river, you do to the other. And this is helpful because now my 8s have canceled out, leaving us with W equals 16 divided by 8, which makes 2. And there you go. Example 4. We're going to solve for S, where negative 12 divided by S is equal to negative 3. This problem might seem really odd in that our variable is on the denominator of the fraction. But we saw in the introduction that if you have a problem that has the variable in the denominator, that's currently dividing. And the opposite of dividing, as the hint in the introduction said, was to go ahead and do its opposite, which is to multiply. And as you know, what you do on one side of the river, you have to do to the other. The whole purpose of multiplying by the S was to make those S's that are on the left cancel out so that I no longer have a variable in the denominator. In fact, I've gotten rid of my fraction altogether at the moment. This gives us negative 12 equals negative 3 times S, which is negative 3S. Okay, so again, I have a number and a variable together. And now I need to get rid of this coefficient of negative 3. So a letter and a number side by side are multiplying. And the opposite of multiplying is dividing. So let's divide by negative 3. And what you do on one side of the river, yes, you have to do to the other. This causes those negative 3's on the right side to cancel out. And then negative 12 divided by negative 3 is equal to positive 4. And that is the value of our S. Now this may seem strange that the variable is on the right and its value is on the left of your equation, but truthfully, it does not matter. It's just fine. It's just something to adjust your brain to. And there you go. Example 5. We're going to solve for y, where the quantity of y plus 7, all divided by 3, is equal to 3. Now this problem frequently makes people a little nervous because not only do we have a fraction, but we have a binomial in the numerator of the fraction. So let's just begin the process of getting rid of the fraction. So something that is a fraction is a different way of saying that we are dividing. And the opposite of dividing, because we're getting rid of that, is multiplying. And what you do on one side of the river, you betcha, you still do to the other side of the river. The whole purpose of this was to make the 3's on the left cancel out, leaving us with just the numerator that's on the left of y plus 7 equaling the product of 3 times 3, which is 9. Hey, this isn't scary now at all. We have y plus 7 equals 9. We know to get rid of this 7, all you have to do is its opposite, and that is to subtract. And what you do on one side of the river, yep, we got to do on the other. This is going to cancel out our 7's, which was the whole purpose, the whole intent, leaving us with y equals 9 minus 7, and that is 2. And there you go. For our 6th and final example, we're going to solve for y, where y divided by 3 plus 7 is equal to 3. Now, there might be a temptation to begin solving this problem in the exact same way that we solved our 5th example, but I'm going to tell you that is a bad idea. The reason that's a bad idea is because this fraction only has a single term on its numerator. The previous problem had a binomial. It had 2 terms in the numerator. So we start this off not by multiplying, but by getting rid of your 7, which is currently adding. So we're going to subtract. We're going to do its opposite on both sides of the river, allowing those 7's that are on the left side of the river to cancel out, creating just a simple y divided by 3 on the left, and the difference of 3 and 7, so 3 minus 7, which is negative 4 on the right. Now it is time to get rid of this 3 that's currently dividing. The opposite of dividing is still multiplying, and what you do on one side of the river, you most definitely have to do to the other. And the purpose of that was to make those 3's that are on the left cancel out, leaving you with y equals the product of negative 4 and 3, which happens to be a negative 12. And there you go.